Before you watch this video, I want you to have tried all of the parts of this prairie dog question. I do have all of the answers written on here, so if you haven't already answered, go ahead and pause the video, answer what you can, and then this video is just going to talk through the answers that I got for these I parts of this question. Okay, I'm going to talk about part A first. If we are describing the relationship, we need to talk about all four different types of things, except for outliers, so I guess that would be three different types of things. There would be a strong negative linear association between distance from the burrow and the frequency of the bark. I should add, and bark frequency maybe. Make sure that you include the context here. The context is going to be really important. You also need to have the words strong, negative, and linear. Our R value is the square root of 82, which is going to be a pretty high number. The second one is to write the equation of the least squares regression line. And we have all of the information that we need up here. This one will be the slope. This one will be our y-intercept. So you can see I did put predicted bark frequency. The regression line is just to estimate what the bark frequency is going to be. And then I just used distance as my second variable here. Part C I have written down here just to save some space. So part C says for every 1 foot further away from the burrow, the predicted bark frequency decreases by 0.2643 barks per second. So the key thing here is that you have the word predicted bark frequency. It is not the actual bark frequency. It's just how much we predict it to change. You should also have something like decreases because it's a negative slope. Part D asks us to predict the barking frequency if the intruder is 90 feet from the burrow. So now I'm going to use my equation that I have here in part B. I'm going to plug in 90 for the distance. And if you plug that in, you should get about 61.48 barks every 30 seconds. Make sure you have the units on here as well. The units are going to be important. Don't just want to leave a number with no units. Part F is asking us the value of the coefficient of determination. That's your R squared value, your coefficient of determination. We do not use the adjusted value. So this does say 82.2. I originally had written the wrong one on there and I had to fix part F. So it's the 82.2%. That is the value. The interpretation, we're just going to throw it into our generic formula. 82.2% of the variation in bark frequency can be explained by the distance from the burrow. Alrighty, moving on to part G. Is it reasonable to interpret the y-intercept of the least squares regression line? And explain why. So the y-intercept, let's think about what that means for a second. That is when the x value is 0. So x in this case is distance. The distance would be 0. The intruder is at the burrow. They're right there. So yes, the y-intercept in this case does make sense. That would be the frequency of the barking when the intruder is actually at the burrow. Let's interpret the value of S. Remember that S is the standard deviation of the residuals. We are told S up here at the top. So we are here in part H. The actual bark frequency is typically 5.001 away from the number that is predicted by the least squares regression line. It's telling us about how far away, how good is our prediction. If we're looking at our residual plot up here, S is telling us about how far away each of these data points are from this line. That would be a 0 residual is right on the money. We estimated it exactly correct. So the standard deviation tells us how far away are we from that line of truth. All right, so last one asks if the predicted barking frequency for a particular distance is 63 barks per 30 seconds. What is the estimated actual barking frequency? So when we're looking here, we are going to estimate, of course, and in this case, we would want to use the residual plot. We're comparing the predicted barking frequency with the actual value. And that is a residual when we take our actual minus our predicted. It's important to note here that if a residual is defined is equal to the actual minus the predicted, act minus pre is what I usually remember to remember the order. So if the residual is equal to the actual minus the predicted, a positive residual tells me that the actual was greater, which means that my line, my least squares regression line, is under predicting because the actual value was larger than what I predicted it to be. So our line is under predicting for any value that's up here. And I did write under predicting. And it is over predicting anybody that's down here. All right, and we are looking at 63. 63 is, oh, sorry, not 60. So 63 is maybe over here, somewhere right in the middle. It is in the top of my graph. So we would have under predicted what the actual value is, which means it's going to be something that's greater than 63 barks. We could make a better estimate here. Let's see, the residual's around maybe 5-ish. So it's going to be something greater than that value, something greater than 63. And I'm going to take 63 plus my residual and get approximately 68 barks per 30 seconds. Again, this is an estimate. It's not our exact value, it is an estimate, but it's a pretty good estimate. Okay. There's the answers for the Prairie Dog Towns question.